Foundation Level Objective 4.2.4 K3. Use state transition testing to derive test cases. You will also get a question about this in the exam. State transition questions don't have a shortcut. It's more like an IQ question. Just use your common sense. First question. In the system shown, the system starts in the init state and ends its operation in the off state. We want to know the minimum number of test cases needed to achieve valid transition coverage. Use your pen and move along the transitions to cover all the arrows without raising the pen, starting from the init state and ending at the off state. Test case 1, test, done. Test case 2, run, error, done. Test case 3, run, pause, resume, pause, done. 3 test cases are needed to achieve full valid transition coverage. Correct answer is D. Second question. A storage system can store up to 3 elements and is modeled by the following state transition diagram. The variable n represents the number of currently stored elements. Which of the following test cases, represented as sequences of events, achieves the highest level of valid transitions coverage? We have 5 transitions, so let us mark them with E1 to E5 to make it easy for us. If you remember, we mentioned the format of the transition label as a trigger/behavior. In our example, the trigger is either add or remove. The guard is the condition that must be true to execute the behavior. N represents the number of elements currently stored. Each add event increases it by 1, and each remove event decreases it by 1. Notice that when the add event occurs while being in the not full state, the state changes to full only if n equals 2. If n is less than 2, the system stays in the not full state. If n equals 0, no remove action is possible. Similarly, if n equals 3, no add action is possible. All these are deduced from the labels on the transitions in the diagram. Let's check how many transitions are covered in each answer option. Notice that there are 2 add transitions and 2 remove transitions. So we can choose either arrow when the option indicates add or remove. Just take good care of the condition guards on each arrow. Test case A. Add, remove, add, add, add can be written as E1, E3, E2, E2, E4. So covers 4 out of 5 valid transitions, achieving 80% valid transitions coverage. Ooh, and I guess the modal answer is explained wrong here. Test case B. Add, 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 remove, remove. This is not possible. The system is in the full state after 3 adds, so we can't have 4 consecutive adds. Test C. Add, 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 remove, remove can be interpreted as E1, E2, E4, E5, E3. So covers 5 out of 5 valid transitions, achieving 100% valid transitions coverage. D. Add, 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 remove. Add can be executed as E1, E2, E4, E5, E4, so covers 4 out of 5 valid transitions, achieving 80% valid transitions coverage. Correct answer is C. That one took a lot of time. When you face questions like this in the exam, leave it to the end. Third question. You are designing test cases based on the following state transition diagram. What is the minimum number of test cases required to achieve 100% valid transitions coverage? As I said before, this is an IQ question. Try to use your pen and get the minimum number of consecutive arrows. Then, count how many times you had to start over to cover more arrows. So let's try it together. Test case 1. Start, requesting, confirmed end. Test case 2. Start, requesting waiting list confirmed end. Test case 3. Start, requesting waiting list end. 3 test cases, so the correct answer is A. Fourth and last question. This time we have a state transition table, not a state transition diagram. You are applying state transition testing to the hotel room reservation system, modeled by a state transition table. Assuming all test cases start in the requesting state, which of the following test cases, represented as sequences of events, achieves the highest valid transitions coverage? The table has 4 states and 5 different events. A transition is represented by whatever table cell is filled. We should count the number of filled cells in the table. So we have 7 valid transitions. Now we should go through each answer option and see how many valid transitions does it cover. Always start from the first row. S1, requesting. A, S1. Not available leads to S3. S3 available leads to S2. S2 change room leads to S1. S1 not available leads to S3 again. S3 cancel leads to S4. This test case covers 4 transitions. B, S1 available leads to S2. S2 change room leads to S1. S1 not available leads to S3. S3 available leads to S2. S2 pay leads to S4. Option B covers 5 transitions. C, S1 available leads to S2. S2 change room leads to S1. S1 available leads to S2. S2 change room leads to S1. S1 not available leads to S3. Covers 3 out of 7. D, S1 not available leads to S3. S3 cancel leads to S4. S4 change room doesn't lead to anything. Invalid test case. So option B is the test case with the highest valid coverage.